Okay, let's continue the signal detection theory, and I'll come back talk about some of the jargons for people who use the 2 by 2 table to evaluate testing. Test and these present. So there are some states related to jargon potential states that. But right now, it would think this problem. You have a very this quality. You have a very distinctive way to evaluate several things at fully loaded problem. Okay, so back to the basic definition. We have 3,000 engine tests and have two. Then, of course, you can still see that 2 by they're really good one judge. And of course, signal detection theory, the condition of and judgment of different problems. People this based on handle no matter what. There is a 2 and why I talk about this 2 later on. I'm gonna and start talking. There are 2 by 2 x1 to x. There's so many things, and we can also evaluate more complex. So it's not one 2 by 2. As a network, a bunch of. Can you imagine you like in a hospital, you can send the body fluid and as patients different. A lot of time, one test, something can be complete. Okay, so that's the big picture we're getting into. Now let's talk about this guy. He basically did not publish. That's good. He didn't make too many mistakes. But then at the same time, miss out of 5. And so, it's intuitively you can think about it. If they price letting a bad engine 1,000, the higher the price. Almost like Homeland Security not raising, stop the 5 terrorists, talking about and the price is very, very high, then you like to capture every one of them. Cost. So graphically, basically said that every time you can change this line a little to the left or further to the left, since I put a noise that you put it over here, you know that almost every bad engine signal will be captured. But the problem is having too many forces. On the other hand, if you said that, oh, I'm say fair, let it go, and you'll have a very, very high threshold for the trigger, then not too many bad engines. So, and now I'm actually playing the devil. It depends. It depends on context, the penalty of false alarm mistakes. It also depends on the psychology. Some people, they are, example, there are this day time, no child accommodate contract for college education, road road way. So they're harsh. Tiny mistakes, corporal punishment. Now, this too sometimes very critical. You'll you'll come at fundamental standing. Okay, so how we did this, I basically show. I think is need to figure out T score relative T score relative to peak of mountain, peak of mountain. Use this two peak location. Find where is the threshold relative to, and you can tell mountain one is here. So DN, D score, this threshold relative to noise mountain is very long. So, and then the threshold signal mountain was very close, and I can tell sometimes, especially the minute I see this is, I know my gut feeling is about close to 2. And then this one, since it's close to half of the mountain, 0. So this PSN should be very, very close to. Computationally, I hope you, at the same time, intuitively, you can see 1 point. And then, of course, the distance one and based on here's my peak, here's my relative to threshold. So the threshold difference, I mean the NZSN phi distance. And I call it knowledge. Okay, the more knowledge, good product, bad product, evaporate. But if there's two mountains, free lunch. I either make. Second thing about the height of, okay, the the mountain for the noise. I know that when I make the cut, since about 0.5 here, so I know the height's gonna be tiny. So the height is point. And then on the other hand, for the second mount, since I know is closer, so I know the height is much in 6. So using I1, the height from the signal side divided by the noise side, I know my beta value is 3. What does that mean? Threshold indicate have an attitude not to pick people products out. Okay? Next, okay, here is the computation. I show you the and how I get my, and then I figure out based on. Yeah, but to understand the mathematical form, basically the normal distribution. And part of the reason I would like you to memorize later on, I'm gonna. So it's not a one-sided, many side and variance structure. It's some intuitions. Okay, I usually call it 1 sigma is my scaling side, and here is my exponential shape. So if you have very tall shape, and then scale spread it out. Yeah, I'm not, you know, personally, if you're Lean Six Sigma fan, could have this. Oh, about the homework. Originally, I thought customer own problem. That's why, for those of you, show, give me a cue to uh, the take home message central limit theorem. Really, just I don't care what distribution get your do some X bar it cannot be. Okay? And I don't give station, but I'll use this. If you're looking at management, very idea, translate math in the statistics, the interview. It's you will ask you where the bell shape coming gets stuck. I consider knowing what is known. Statistics for us abuse should be common sense. And here is 6 coming from, and here, okay, I'm here, you're here. Difference relative to threshold delta. Okay, and as such, we can have an expected cost. Here I only give, we have cost of hit, $50. We have cost of miss. We have cost of false alarm, means I open a good product. And of course, I don't have correct rejection or benefit. But, you can put value there. And everyone expected value depends on this. Hey, what's the cost or benefit of hit? So the first is a dollar sign. But then after that, the two chain probability. Given is a signal. And given, what's the probability that I say something? So first you have to be, in a something wrong group, and then I. So this is a chain of the probability. Here is the chain rule. Something wrong, but I miss it. Probability of I miss. Then there's a price. Okay? And similarly, there's a norm. So here we have a price of 27 by 2 per. And since we're doing 3,000, the inspector 1, his expected cost, A2552. One way, following. Remember at the beginning? Already know that if we don't hire anybody and let people back and causes, now the inspector cost. So his salary should be difference between. Yeah, if we pay him more than that, occasionally, probably say, okay, and something. Let's do it for Inspector 2. Okay, Inspector 2. This time, he is the grumpy man. Remember? So grumpy old man, false alarm order. And then, but on the other hand, only. Okay, and have the hit. Like reject. Remember the 10 rule. Given as a signal model. Given a signal model. Yes. Given a noise bound. So PN, PSN. Hope you follow the 10 rule. Now again, this time you can tell. Okay, I will have a so now I'm gonna compare this amount. And first thing first, okay, for ZN is tiny. No, it's not tiny. It's about 0.48. 0.48, let me ask you this. The sticks should be on the right side left side. If it's a 0.5, it's right here, right? So it's probably a little bit here, yeah, but it's pretty close to the 3. And then for hit, okay, I have 80% of hit. So I know that, to agree with me, I'm on the left side of the signal mode, left side of the peak. Okay, and so yeah, that's why I want to copy paste. So now you know that for this one, for the ZSN, okay, is negative 0.84 because it's on the left side of the map. And then on the ZN is on the ZSN, so the two mountain is 0.84 and negative 8. And remember, if I'm using this minus, really we're saying is 48.48 plus total distance. Okay, and next, okay, on the height. Okay, first look at the height. Look at B. First, the noise mountain should be taller than the signal mountain. So what happened here is that if signal mountain is smaller than this, and what does that mean? Is that knowledge-wise, is one, and the threshold is 788. And remember, at least why the beta value for inspector 1 is 3 something. And so you can tell this guy is trigger. He's very jumpy. So his threshold is okay. And knowledge wise, okay, look at his knowledge. It's 1 point. And if I get the look at the vector 1, his knowledge is 1.366. So knowledge wise, he's not as good. Vector 2's knowledge is not. But in this case, and I've been IQ, there are, and I found signal detection sometimes now and 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 accordingly, okay, the expected cost a lot cheaper, or a lot lower because he is net. So he capture bad guys. His expected cost is 501. Other one, and I would say not in quality policy. Even sometimes in some Asian, a lot of times they don't have, but the teacher, so the overall and patients here would a lot cheaper. Filter out the bad and bad students past the, and of course now you get into the argument that the purpose education education also argue quality control a lot of times not just bad and out there. So no, we defend our decision based on that, but there's always that touchy think about. Okay, now I would like to find the optimal. No, you probably will say that. Well, can I uh, find a way? Say that, hey, Inspector, go Inspector Two. I'm sorry, Inspector One. You're too. Make it hot. Inspector Two can soften. Basically, how to find that threshold, the cut somewhere in between, such that your overall cost, the expected cost, can be reduced. So the expected cost, that equation. And then now I'm going to write the expected cost of the equations. Basically said that I'm going to call the CDF based on an optimum location X star. And this X star, if I do it right, okay, for my FSN, or in the miss is 1 minus FSN, side or right side, or correct rejection, course or left side or right side noise mount. Okay? So it's the integral on the left. Oh, this should, and once I write this, okay, I am doing this, then I can take the derivative, minimize the cost, and first derivative, and I'm not going to do the second derivative, try to figure out where the equation. Know that cost, no matter what, will be too much either way. And wrong judgment, either let go to or increase. So where's the minimum is first derivative. And when you try to do the first, knows that all the given terms in the problem that can say what can be changed is CDF becomes PDF. And once you do the PDF, 1 minus 1 disappears, negative. Yeah, so it's just 4 term PDF, CDF, and this 4 term linearized. So what is my beta star? Is my attitude. Depends on the signal amount versus equal to a value or value of correct rejection, and value is positive, plus is negative. Oh, by the way, something I found that guys take professors, uh, you know, for risk management, a lot of time you, and then a lot of time you're talking about product utility. No matter what, uh, is a dollar sign. Okay, value in cost is negative. Once you times them, time those things based on ability is the expected value. So in this case, we say that how high of this things or how low is this thing for the height of the signal mode depends. These things need to, if we want to make this thing small, okay, we want to make beta star small. How to make that small? Beta is if I have a lot of noise and not too many signal, then you know that you tend to have to down lower your threshold. The other thing is that if correct rejection is false alarm and price of hit minus the cost, just look at here. Okay, if the hit 800, 8,000 to 80,000, the more value here means what? Catch one bad guy worth a lot, then lower the threshold. Okay, so hope this way differential derivative and your okay. And now let's do this in mathematical. So beta is star is based on the height a of b. So is the square root 2 by square root 1 over square root of scale cancel out. And show half of the upstairs minus down. Right? And then take log on both sides. Log beta becomes negative half, basically exponent. So far so good. First equation. And then the second equation is copy paste. Know that the distance is noise mount signal mount. So now I have two simultaneous equations, and I try to figure out where should I make my cut. And those are on knowledge and beta, I know. So ZSN and well, one simple you can do equation together, ZSN Z. So half of guy and ZSN ZSN negative Z MB. So algebra. Okay. Now, so for inspector 2, basically said based on the cost structure and based on how likely we can have a noise and how likely your beta star could be 7 and his beta so 1. So we basically said, hey, move this a little bit. So and increase threshold a little bit left. So we're basically trying to come. My inspector too basically said, "Hey, I want you to have different yen and Z." Basically said, "Don't be so tight. Let it go a bit." Okay. Now I can do the same things, vector one, and I'll let you do it. I'll probably come up with a, or let you different setup number, very uptime, and adjustment. Okay, things run a little more complex than our high changing. Here's the question, especially in or thing we can change like a uptype or make some so fast. You give too many, you need to make. How likely you I would say this or sluggish beta. Basically, people change their immune. So if you tell them red alert, they can change the behavior. So you continuous and sometimes best way. So, so you can have problem. Okay, that's good. But what I really think about this, okay, and I argue, not argue, discuss with Dr. Lee. He is Dr. Kazu. It's the following. I'm a human factor. I do really change as them be. Then probably can. That's the case. I go for it. And I found objective function give us a sense of. So to admit, now I can. So at least I have some numbers. What's the what's the attitude, and how can just one benefit of the other? Okay? Now, 15 minutes. 11. So I have a few more minutes, and you find something. Ever heard? Okay. And let me do ROC curve. Yeah. The reason I skip certain slide is now, since I'm teaching, I always cover the material self-contained, so I can give you a and the sidetrack. Oh, this also explain ABs. Cover them after I what can be. Now, what is ROC curve? Is the following. Okay? We're basically doing the. Oh, by the way, first let's just say this. ROC curve is I give people situation under very hard situation. So in other words, look at here. I have a 120 signal and half noise. So in other words, there are more bad guys than good guys. 2 to 1. And then of course I have pretty good. And then all the way to a bunch of good guys. 120 bad guys. Okay? So I give people then at the end evaluate under DNZSN, therefore their knowledge. And so regardless, we know that it's possible. Some people they are goofy. Okay? In minute we give them challenge how they become. And if that's the type of people, then they're opposite. No matter what. So here, just using a bunch of those situations. And let me go back here. So if I do that, know that rather than just one 2x2, I just have tons of 2. And then for tons of 2x2, okay, I can find their so for each one of them, I would like to first identify their probability of hit, of probability of uh, false alarm, this side, and probability of hit. So you see I copy 0.87, 5.8, 16.64. So I copy this row, put them in pair. Okay? And what is this pair really means? What each is the probability say yes. I say yes, and there's nothing. I said yes. So I'm basically or document when they say yes. And then, of course, I can evaluate this set. And after I've done this, I will have add two more when there's absolutely nothing. There's and then where I add a zero pair, make the graphics easy to understand. Okay, so now let's look at the. Okay, now this is called the additional C curve. Okay, and let me add a shape. This is our C curve. Okay, x-axis, y-axis, and if you do this, you'll see that if I have a diagonal, what is that? It's density of say yes, there's nothing, or so. Hey, is this guy a bad? Is this a bad product? Let me toss my. I don't care. You have majority are bad guy or majority are good guy. My attitude. Not good. So technically, we would like to have this okay, go as close to the diagonal as possible, almost like the elbow. That means what? There's nothing, but when there enough for me to say there's, I'll say. So based on that, which curve closer to the 50 blue one, and the pink one is so. Which one you probably know more situation? Pink one. So the further away, got is a decent key judge. Okay, I will tell you. Oh, Gilroy, majority. Oh, okay, just a little bit. Finish. So a lot of times, low back pain. Meaning, so how to judge someone's time imaging, and so publishing that time out, and read that paper. Still working. They show back some Then they ask, use the picture. Guess what's there? That's simple. And so, if that's the case, what's there? So, uh, I'm going to show you how to do this, and I will show you how to linearize differences. But the key here, you don't want to just talk about it, quantify. Then our okay, see you. So